Hi everybody, this video will go over section 4 of chapter 9, and here we're going to talk about partial fractions decompositions. Now, previously in this course, particularly in chapter 1 and in chapter 3, when evaluating rational expressions, the practice has been to take an expression and to write it as one fraction, and then set it equal to whatever it is we're trying to evaluate against, whether it be 0 or another variable y, and then from those we can determine what values of x satisfies the statement. Well, in partial fractions decomposition, we are going in the other direction. We are going to start off with a single fraction that has a denominator that can be factored, and then we are going to express that into a number of terms where each term is one of the factors in the denominator, and we call that the partial fractions decomposition of a rational expression. And this technique finds a number of applications, particularly in calculus when evaluating integrals of rational expressions. Okay, so how does this work? Well, I'm going to go through the procedure. It's not going to be very instructive, and once I've done that, then we will illustrate that in 4 examples. The first thing you want to do is you want to check to see if our expression is a proper fraction. If it's not a proper fraction, well, then that means that the degree of the numerator is greater than the degree of the denominator. So we would need to divide the numerator by the denominator to get a quotient and then a remainder, which of course will be divided by the divisor. This will be our proper fraction. Once we have our proper fraction, we can apply the next steps to this expression right here. And the first thing that we're going to want to do is to factor the denominator completely. Okay, and if we do that, we will have terms that look like ax plus b, or ax plus b to the nth power. This is a discrete linear term. This is a linear term that has been repeated n times. Or we're going to have a quadratic expression which can no longer be factored in the real number system, such as cx plus squared plus dx plus e, which would be a single quadratic factor, or we will have a repeated quadratic factor, which would be essentially the same factor repeated m times. Once we've done that, we will write the expression as follows. If we have a discrete linear factor, we will include a term that is some constant divided by ax plus b, that factor. If it is repeated, then it will be a constant divided by, we will add a constant divided by ax plus b plus another constant divided by ax plus b squared, and we will continue this until we get all the way up to the highest power. Then for the quadratic factors, we will do the same. For the discrete quadratic factor, we will write the numerator as bx plus c, and then we will have the discrete factor in the denominator. If it is repeated, then we will have b1x plus c1 divided by that factor, bx2 plus c2 divided by that factor squared, all the way up to the number of times that has been repeated. And then once you've done that, we are going to use algebraic techniques, probably a little more detail here, to figure out what those constants are in the numerator. And the next examples will show you how to do that. Okay, so here's our first example. We want to find the partial fractions decomposition of 3x cubed minus 3x squared plus 7x minus 4 divided by x squared minus x. And to do this, since this might require a little bit of space, I'm going to go over to OneNote. And here we are. Okay, well, notice here that we have a numerator with a degree of 3 and a denominator with a degree of 2. This is not a proper fraction, so we need to divide the denominator or the numerator by the denominator, and we need to do that using long polynomial division. So we're basically going to set that up the way we learned in years gone by. This is the divisor, and then we're going to divide this our dividend by the divisor. Okay, now the very first, what I first want to do is basically multiply x squared minus x by whatever I need to get a 3x cubed term here, and that of course means I want to multiply this expression by 3x. If I do, I will have 3x cubed minus 3x squared, and when I subtract them, these will cancel, and I'm left with 7x minus 4. Okay, and now since the degree of this is less than the degree of the denominator, this is as far as I need to go. And that also means that this is going to be equal to 3x plus 7x minus 4 divided by x squared minus x. So all this is step 1. Okay, and then for the remaining steps, this is the expression that I want to work on. Okay, so let's go ahead and bring that down. That is going to be 7x minus 4 divided by x squared minus x. Step number 2 is to factor the denominator completely. Well, the denominator will be factored completely when I factor out an x, and that will give us x times x minus 1, and we will have two linear factors, and that's actually the best you can do. Of course, we're going to bring the numerator over. That's going to be 7x minus 4, and that takes care of step 2. Now, step 3 is to do the expansion, at least for the linear terms. Okay, so this is going to be equal to some constant, I'm going to call it a, divided by the first linear factor, which is x, plus some other constant b, divided by the second linear factor, which I'm going to call, which is x minus 1. Okay, that takes care of 3. As far as 4 is concerned, there are no quadratic factors, so we're left with basically trying to figure out what a and b are in step 5, and that really is the meat of the problem. So we're at step 5. Maybe just rewrite this a little bit. Plus b divided by x minus 1. Now the first thing that we want to do is we want to create a common denominator. So I'm going to multiply this term by x minus 1 over x minus 1. I'm going to multiply this term by x over x. And then what I'm going to have is that 7x minus 4 over x times x minus 1 is going to be equal to a times the quantity x minus 1 plus bx, and all that is going to be equal to x divided by x minus 1. So notice that the denominators are the same. I can multiply both sides of the equation by x times x minus 1 x times x minus 1 here. This cancels that. This cancels that, and I am left with 7x minus 4 is equal to a times the quantity x minus 1 plus b times x. Okay, now there's a couple approaches that you can use. The first approach is you can compare like terms. And the way you would do that is you would expand the right-hand side and basically collect all the like terms. And if you did, you would have 7x minus 4 is equal to ax plus bx. So that is going to be x times the quantity a plus b times, and then minus a. Okay? Then, for this statement to be true, the linear terms, or the terms of degree 1, must be equal, and the terms of degree 0 must be equal. Well, that implies that negative 4 must be equal to negative a, or a is equal to 4. And that also implies that, from the linear terms, that a plus b must be equal to 7. Since we know that a is going to be equal to 4, we're going to have that 4 plus b is equal to 7, or that b is equal to 3. So our solutions are going to be that A is equal to 4, B is equal to 3. The other way is to choose certain values of x. Now let's take a look at this equation right here. What you'll notice is that we have a term here that is b times x. So if we let x equal to 0, the term with the b in it is going to go away. So let's go ahead and do that. Let's let x be equal to 0. And if we do, we are going to have 7 times 0, which is 0, minus 4 is equal to a times 0 minus 1 plus 0. Or that negative 4 is equal to negative a, or that a is equal to 4, which is exactly what we got before. Now also notice that if I let x be equal to 1, then this term will go to 0, and we're only left with b. So let's let x be equal to 1. And if we do, we are going to have 7 times 1 minus 4. That is going to be equal to a, which by the way is 4, times 1 minus 1. Well, that's 0 anyways. Plus b times 1. Okay, this is 0, this is 3, and that's going to be equal to b. So we get the exact same solution. So the answer for this this decomposition can be written as follows. It can be written as, well, let me write out the first part. We have 3x cubed minus 3x squared plus 7x minus 4 divided by x squared minus x, and it can be written as this. Okay, first thing we have is plus 3 is the 3x term, and then we have the partial fractions decomposition of this, and that is going to be equal to 4 over x plus b divided by x minus 1. That will be 3 divided by x minus 1, and it is indeed true that this is equal to that. Okay, let's take a look at our next example. This example here is one with a repeated root. So here we have a repeated factor. We have the factor in the number x minus 3. It's repeated 3 times. Okay, first let's take a look at our numerator. Our numerator is of degree 2. The denominator is of degree 3. So we don't need to worry about doing any polynomial divisions. We can just go straight ahead. So if that's the case, based upon the fact that we have a linear factor that's repeated 3 times, this is going to be equal to some constant a divided by x minus 3 plus some other constant b plus some other constant b divided by x minus 3 squared plus another constant c divided by x minus 3 cubed. And yes, I created some space here because I need to make my common denominator again. So remember, I want these to have the common denominator of x minus 3 cubed. So to make that happen, I'm going to multiply top and bottom of this term by x minus 3 squared. Top and bottom of this by x minus 3. And I don't need to multiply this by anything since it already has the common denominator that we're looking for. Okay, so now that they all have common denominators, the common denominators can factor out or be multiplied out, and then we will be left with this. X squared minus 4x plus 7 is equal to a times x minus 3 squared plus b times x minus 3 plus c. Okay, so to approach this, once again, we can go ahead and we can basically group and evaluate like terms, or we can use certain values of x. And we're going to use the latter, certain values of x. For example, notice here that we have a term x minus 3 here, and a term x minus 3 here. So it might be reasonable for us to let x be equal to 3 and see what happens. And if we do, well, we're going to have 3 squared, which is 9, minus 3 times 4, which is 12, plus 7, and that is going to be equal to a times 3 minus 3, which is 0, plus b times 3 minus 3, which is 0, plus c. All this is equal to c. Well, 9 minus 12 is equal to negative 3. Negative 3 plus 7 is equal to 4. So we're going to have that 4 is equal to c, and that tells us that c is equal to 4. Okay, so that takes care of that. So now we need to come up with 2 different values of x. But before we do that, what I can do is I can get rid of the c and put in a 4, because that's what c is. And of course, if we want to come up with different values of x, we want to come up with values of x that are easy to compute, like maybe x is equal to 0. Nothing's easier than trying to evaluate a polynomial when x is equal to 0. And if we do, on the left-hand side, we're going to have 0 minus 0 plus 7. So we will have 7, and that is going to be equal to a times 0 minus 3 squared. So a 0 minus 3 squared plus b times 0 minus 3 plus 4. Okay, I can bring the 4 over. That's going to give me 3 over here. And that's going to be equal to, well, 0 minus 3 is negative 3 squared is 9. So that's 9a minus 3b. Now, this equation has a common factor of 3. I can get rid of that, and that's going to give me that 1 is equal to 3a minus b. And that's as far as I can take that one. Okay, what is the next easiest value of x to work with? What about x is equal to 1? Okay, that might be a good one. So let's try that one. On the left-hand side, we will have 1 squared, which is 1, minus 4 times 1, minus 4, plus 7. And that is going to be equal to a times 1 minus 3, which is going to be negative 2 squared, plus b times 1 minus 3, plus 4. Okay, now this is going to be 1 minus 4, that's negative 3, plus 7, that's 4. So we have 4 is equal to negative 2 squared is 4 times a minus 2 times b plus 4. The 4's cancel. We have that 0 is equal to 4a minus 2b, or that 4a is equal to 2b, or that b is equal to 2 times a. Okay, well, if b is equal to 2 times a, then I can take this expression and use this to substitute b for a, and that's what I want to do. And that is going to give me that 1 is equal to 3 times a minus 2 times a, or that 1 is equal to a. So now I know what a is. A is equal to 1. What do I have left? What I have left is to figure out what b is, and I can use this equation for that. Well, if a is equal to 1, b must be equal to 2. And if that's, and therefore, and then I have my solution. And that is that x squared minus 4x plus 7 divided by x minus 3 cubed is equal to a times x over 3, where a is equal to 1. 1 over x minus 3. B is equal to 2, so it's going to be plus 2 divided by x minus 3 squared, plus 4 divided by x minus 3 cubed. So this right here, I'm sorry, that one there got in the way, is going to be our partial fractions expansion, decomposition for that particular fraction. Okay, so now for this one, we have a linear term, and we have a quadratic term. Okay, so this one is going to use both steps 3 and 4. Now first notice that in the numerator we have a polynomial degree 2. In the denominator we have a polynomial degree 3, so there is nothing to divide. So what we need to do is go ahead and write the expansion of this. And recall when you have a single discrete linear factor, we want to write this as a divided by that factor, which is going to be x plus 4. And then for a discrete quadratic factor, which is what we have here, and what this is, we want to write this as plus b divided by, bx plus c, bx plus c divided by x squared plus 1. And also notice that this can no longer be factored into real line. If you actually tried to factor this, you would have x plus I times x minus I, and we cannot use any complex numbers. Okay, so we are going to have that 8x squared plus 10x minus 3 divided by the product of x plus 4 and x squared plus 1 is equal to a divided by x plus 4 plus bx plus c divided by x squared plus 1. Okay, first thing we need to do is make a common denominator. So I'm going to multiply this term by x squared plus 1 over x squared plus 1. And I'm going to multiply this expression by x over 4, x plus 4 divided by x plus 4. Okay, and what will that give me? That will give me a times the quantity x squared plus 1 plus bx plus c times the quantity x plus 4, and all of that is going to be divided by x plus 4 times x squared plus 1. So notice we have common denominators. We can multiply the denominators out, and then we will have that 8x squared plus 10x minus 3 is equal to a times the quantity x squared plus 1 plus bx plus c times the quantity x plus 4. Now notice that we have, and once again we are going to substitute various values of x to come up with 3 equations that we can use to solve for a, b, and c. So notice here we have an x plus 4 term. So if actually let x be equal to negative 4, this term will go away. So let's go ahead and do that. Let's let x be equal to negative 4. And if we do, we are going to have 8 times 4 squared, so it's going to be 8 times 16. 10 times negative 4 minus 40 minus 3. That's going to be equal to a times x squared, which is going to be 16 plus 7. This will be 17a. And this will be 0. So this is what we have. And then this simplifies to 85, which is going to be equal to 17a. Dividing both sides by 17, you have that a is equal to 5. So we know that a is equal to 5. Okay? Or more importantly, that this is equal to 5. And we can also make that change here. A is 5, so this is now 5. Okay, so what else can we do? Well, what about what we did before? Let's let x be equal to 0. Okay, if we do, we are going to have on the left-hand side that negative 3, 0 plus 0 minus 3, negative 3 is going to be equal to 5. Okay, 5 times 1. 5 times 0 plus 1, so that's basically 5. Plus, there's no b. That will cancel, right? So it's going to be plus 0 plus c times 0 for x plus 4. So what do we have? We have negative 3 is equal to 5 plus 4c, or negative 8 is equal to 4c, or negative 2 is equal to c. So now we have that c is equal to negative 2. And this right here is equal to minus 2. So the only thing we have left is b. Okay, so let's do the next easiest value of x to compute. That's going to be x is equal to 1. And what do we get if we have that? Well, we are going to have 8 times 1. Well, that's 8, I think. Yep, 8 times 1 is 8. Plus 10 times 1, which is 10. Minus 3. Okay, that is going to be equal to 5 times 1 squared plus 1 squared plus 1. So that's going to be 5 times 2, or 10. Plus b times 1, that's just b, plus c, that's a minus 2 because c is minus 2, times 1 plus 4, which is 5. Now this is going to be 8 plus 10, which is 18, minus 3, that is 15. And that's going to be equal to 10 plus 5b minus 10. So these cancel. We have that 15 is equal to 5b. And dividing both sides by 5, we have b is equal to 3. So b is equal to 3. And that implies that this right here is equal to 3. And that is our partial fractions decomposition for this particular fraction. And that brings us to our last problem, which is a bit of a bear. This might actually take a little bit of time. Okay, so here we are. We want to find the partial fractions decomposition of x to the fourth plus 3x cubed plus 4x squared plus 2x plus 4 divided by x times x squared plus 2 with squared. So this factor is repeated twice. But nonetheless, we don't need to worry about factoring the denominator. It's already factored for us. And furthermore, notice that the numerator is a polynomial of degree 4. So this is degree 4. The denominator is a polynomial of degree 5. So we don't need to divide anything out. All we need to do is go ahead and do our partial fractions expansion. Now notice that we have one discrete linear term. So that is going to give us an a over x. But now we have a repeated quadratic term. It is basically a quadratic term raised. It is a quadratic term. Well, I see I finally noticed a typo here. This should actually be the repeated factor cx squared plus dx plus e to the nth power. But notice, once again, it is to the nth power, so I'm going to have this term, x squared plus 2, and then this squared, x squared plus 2 squared, since my n happens to be 2. So that is going to give me plus bx plus c divided by x squared plus 2 plus dx plus e divided by x squared plus 2, the entire thing squared. Okay, so let's go ahead and rewrite this down here. We are going to have x to the fourth plus 3x cubed plus 4x squared plus 2x plus 4 divided by x times the quantity x squared plus 2 squared, and that's going to be equal to a over x plus bx plus c divided by x squared plus 2 plus dx plus e divided by x squared plus 2, the entire thing squared. Okay, so the first thing we want to do, as before, is to create a common denominator. And we can do that by multiplying this term by x squared plus 2, the entire thing squared. Both top and bottom. Okay, now for this one, we want to multiply this by x times x squared plus 2. And you also want to do the exact same thing in the denominator, x times x squared plus 2. And then for this term, we want to multiply both terms by this term by x over x. Once we've done that, we have a common denominator, and the common denominator can go away. And this is what we're going to have. We are going to have x to the fourth plus 3x cubed plus 4x squared plus 2x plus 4 is equal to a times x squared plus 2 squared plus the quantity bx plus c times x times the quantity x squared plus 2 plus dx plus e, all that times x. Okay, so notice that this term has an x in it, and so does this. So one of the things that we can do is we can let x be equal to 0. Then we will have, well, all this is 0 plus 0 plus 0 plus 0 plus 4 is going to be equal to a times 0 plus 2 squared plus, well, here we have a 0 in it. Here we have a 0 factor. That's 0. And here we have a 0 factor. That's 0. So this is what we get. All right, this is going to be 4 is equal to 4a, or that a is equal to 1. So a is equal to 1. And we can write this as all this 4x to the x to the fourth plus 3x cubed plus 4x squared plus 2x plus 4 is equal to x squared plus 2 plus bx plus c, well, plus the rest of it. Okay, now that we've done this, there are two ways that we can go. One is we can try to look at when x is equal to 1 and x is equal to -1, and that will get a little complicated. We'll kind of get some numerical growth, and it's going to get a little messy. So this is one of the situations where what you want to do is you want to group and evaluate like terms. To do that, you want to expand the entire right-hand side. And if you do, you are going to have x to the fourth plus 4x squared plus 4 plus b times x to the fourth plus cx cubed plus 2bx squared plus 2cx plus dx squared plus e times x. And that's going to be equal to x to the fourth plus 3x cubed plus 4x squared plus 2x plus 4. Now notice there are some things that will cancel right out. For example, we have an x to the fourth here and an x to the fourth here. I have a 4x squared here, a 4x squared here. I have a 4 and a 4, so they are gone. And I'm left with an x3x cubed and a 2x squared. So now, so let me bring those down. We have 3x cubed plus 2x, not 2x squared, but just simply 2x. And now what I want to do is I want to rewrite this grouping all of the terms with the same degree. For example, for terms of degree 4, I only have one, that is bx to the fourth. For terms of degree 3, I only have one, that is plus cx cubed. Now for terms of degree 2, I have two terms. I have 2bx squared and then dx squared. So this could be written as plus x squared times 2b plus d. And then finally, as far as linear terms is concerned, I have x, that's going to be times 2c plus e. And now I want to evaluate the like terms. For example, because this cannot, the only way that this statement can be true is if the coefficients for each term, the only way that this statement can be true is if the coefficients of each term of the same degree are the same. So notice there is no x to the fourth term. Okay, the only way that can happen is if b is equal to 0. So we have that b is equal to 0. Okay, there is also, yeah, b is equal to 0. Okay, so there we go. Also, for terms of degree 3, we have that c is equal to 3. So for terms of degree 3, we have that 3x cubed is equal to cx cubed, and that implies that 3 is equal to c. So we have that a is equal to 1, we have that b is equal to 0, and that c is equal to 3. Now look at the linear term. Look at the quadratic term. Now for the quadratic term, we have no quadratic term on the right-hand side. So for the right-hand side, for the quadratic term, we are going to have that 0 is equal to x squared plus times 2b plus d, or that 0 is equal to 2 times b plus d. All right, well, b is equal to 0. That means that 0 must be equal to 0 plus d, or d, and that d is equal to 0. So now we have that d is equal to 0. And then finally, we want to compare the linear terms. And for the linear terms, we are going to have that 2x is equal to x times 2c plus e. Okay, well, the x's cancel out. All we have is that 2 is equal to 2c plus e. C is equal to 3, so we're going to have that 2 is equal to 6 plus e. And that implies that e is equal to minus 4. Okay, so now we have that e is equal to minus 4. I do believe we have a value for a, don't we? There it is, a is equal to 1. And so now we can actually write our answer. We can write our expansion. A is equal to 1, so this becomes a 1. B is equal to 0, C is equal to 3, so this becomes 3. And then D is equal to 0 and E is equal to minus 4, so this is going to become minus 4, and this right here will be our answer. And that is all I have for this particular video. If you have any questions, please feel free to contact me. This is Bob Boyle, signing off.